All right, so we're recording. Now, here's what we got here. We got 4 groupings of a 24, a 25, a 26, and a 27. So what if we're to do it like this? So what if we're to do maybe LA up here, SD, and Y, and SF. Okay, now what this is doing, what this whole exercise is doing is getting you used to using smaller subnets. And typically you'll want to use the smaller subnets for things like your point-to-points. Like your /30s there, yeah, you'll probably want to break it up by I think in the next assignment or the assignment after that, we're starting to do /30s, right? So recommendation here. For the LA side, use the smallest subnet for your point-to-point, for your router there. Okay, so why don't we use the 10140/27 here? 1014. So that's going to be used there. Okay, the 26, 25, and 24. Typically, you're going to have more users than servers, right? So let's do it this way then. So let's do the 10110/24 for the users. 10120 /25. We'll use that for the servers. And you notice here too that there's one extra link here. One extra link here for router to router. /26 here. Okay, is that making sense? All right, I could be really mean and say you can't use subnet 0. But I'll give you a break. We can use subnet 0. Okay, so that means the 0 block there, that's right there for /25. Yeah, your first host and your last host. So you calculate that out just like how we did yesterday, right? You do the same with the 26 and a 27, and we already kind of know what a first and last and broadcast is on a /24, right? So if we're going to follow this logic here, 10180/27. Okay, and this point-to-point link to another router, 1017/26. This is 1015.0/24 and 1016 over here. Okay, more of the same. More of the same for the NY side here. Uh, 10.1.6 is /25. Okay, NY side is 10.1.12 /27. This side right here, 10.1.11 /26. And then 10.1.10.0. Yep. Okay, more of the same, SF. Ten one 15 26 13 It looks like I have to correct that misspelling. 10.1.14.0/25. Okay. Okay, for a /24, first host is 1, last host is 254, right? And this is on block 0. /25, first host is 1, last host 126, and we know why, right? Let me know if you want to see it in binary or if we're good. Okay, /26 on block 0. First host is 1, last host is 62. Okay, then a /27 on block 0. First host 1, last host 30. Because you're going up in increments of 32 there by that time. /26s, the networks go in increments of 64. /25s, the increments go in 128. Oh, well, you're only going to get 2. /24, you only have 1 network. Okay, so that means We bring up our topology here. We're going to pause the recording for a second. What's that? Okay. All right, there we go. All right, so here's our blank topology. So over on this side, 10, 1, we're just gonna copy this down. 10.1.2.0/25. Okay. We also have over on this side 10.1.3.0/26. And then over on this side is 10.1.1.0/24. Okay, this side, 10.1.4.0/27. Okay, 10.1.8.0/27. Ten 1.12.0/27. Over on this side, 10.1.16.0/27. Right, so your core router there is going to have all of your /27s. Okay, that is your transit router. Okay. 10.1.7.0/26 is over here. 11/26. This one is 15/26. Okay, then 10.1.5. This one's 10.1.6. Right, and this one is 10.1.9. And this one is 14. And this one is 13. Okay, so what you'll want to do then is figure out all of your labeling. Okay, 10.1.2. Last host on a /25 is 126. Subnet mask, 128. Default gateway, 10.1.2.1. And since this one is the server here, yeah, LA server is also going to be the DNS and the web server. So it is 10.1.2.126. Okay, because that's using, we're going to go with the same pattern of using last host IP for the host next to last for the switch. Okay, so IP here It's 125. Ten, 1, 2, 1. Okay, and this is dot 1 over here. Okay, and this is also dot 1 over there. We'll make dot 2 over here. Okay, this is 10, 1, 1. 10, 1, 1. Last host here is 254. Right, and 10, 1, 10, 1, 1, 1. $253, it's right there. Subnet mask is this, default gateway. Okay. All right, cool. By the way, the videos from last night's lecture session, everything has been posted already. It's in the training videos if you haven't checked it out already. Okay, and it's pretty safe to assume here that our core router is going to be dot 1 for everything. Okay, so that means dot 2 is over here. Dot 2 is over here. Dot 2 is over there. Dot 2 is over here. Pretty much following the same pattern, just like all of our other exercises too. Okay, so 10.1.7, this particular network here, yep, 10.1.7, we'll make dot 1 over here, dot 2 over here. Okay, this is the 5 network over here. That means 1 is here, then 254 is down here, because this one's the /24. Okay, this is the 6th network down over on this side. Are we tracking okay? Are we tracking okay? Looks pretty straightforward. Right, so yeah, if you get one side going like this, then all the others are gonna be just the same, and it's your same wax on, wax off exercise there. Just getting you used to the fundamentals. Recording. This is actually the /25. So subnet mask is 128. And 126 is the last IP, so 125 is over here. So this means this is 126 over here. So it's 126. Okay. Default gateway 10161 DNS is 10.1.2, should be 126, right? 10.1.2, 126. $253. Okay, default gateway 10.1.5.1. Okay, and that should be good there. And 254. And 151. And 126. Okay, so this side will be .1. This side will be .2. Okay, IP 10.1.10. This is on the 10.1.10/25. The same thing. And 110, 126, 128, 10, 110, 1, DNS, 10, 1, 2, 126. Okay, this one's straightforward. Default gateway, 10191. Okay, this is the 14 network that's right up here. Okay. All right, so 10.1.14, this is the /25 side. 125 is over here. Okay, IP 10.1.14.126. Okay, 10.1.13 network. Okay, so this is the blank topology. And this is, yep, everything we talked about on the PDF here. Okay, so now it's just a matter of configuring it. So go ahead and configure everything. Make sure you're routing right from LA 2911. So I'll probably give you a hint here. Right, so for something like this, so if we were gonna do IP route for the /24, right, we're gonna need to go up to this next neighbor. So we're also gonna have to route for 10.1.3, and we're gonna have to route for 10.1.2 up here, right? So first one over here, 10.1.10/24. /24 is like this. And next hop IP, 10142. See, 10142. Okay. Next one, to route for 10113. Or actually, we can do it in order here. 10120. IP route 10120 /25 is this subnet mask. Okay, that next hop IP is 10142. IP route 10113 /26. It's 192. Okay, 10142. Okay, so likewise, this LA router, it's going to be routing for all these other networks. Next hop IP is 10141. The one exception here is to get from here to the 10111 network. That exception is right here. The next hop IP to get to this network is 10132. Okay. Now, since we had our fun with the assignment 4, why don't we take this time and get it all configured? Okay. So I'll release you on your own now, and let's see how far we can get. Okay. All right, for core router, for the for routing here. Okay, what you'll probably want to do is do something like this: IP route 10111, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, along with the respective subnet masks, right? And then just kind of this is the next hop IP, right? And same strategy like last week. Anything that is directly connected to this 2911 router, we're going to ignore it. Right, so 1014, we are not concerned with 1014. We are not concerned with 1018. We are not concerned with 10112 because it's already directly connected. We are not concerned with 10116. Okay, now 10142, we already figured these out from the top up here. And those are all going to the next hop up here. Okay, so that means you'll probably want to take this again and go from the LA 1941. Right, so go ahead, reset, 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 right? So all of these, you're going to be routing for all these. Okay, the 10.1.1 network is going to be out 10.1.3.2. Okay, the 10.1.2 network is directly connected, so you're not concerned about that. Not concerned about the 10.1.3 network, and not concerned about the 10.1.4 network. So you see how that's kind of working there? So 10.1.3.2. 10.1.3.2 is up there, right? And that doesn't really matter. But for the rest of these routes, the 10.1.5, 6, 7, 8, 9, all the way up to 16, from this router's perspective, its next hop IP is going to be 10.1.4.1. 10.1.4.1. So you could find and replace. We're going to replace all those with 10.1.4.1. Okay, and we'll just replace all. There you have it. There are all of your routes for LA 1941. So then you're probably going to want to do the same thing for the LA 1941 too. I'm probably just going to take another one, take another copy of this. Right? So from this perspective right here, LA 1941 2, it is not concerned with the 10.1.1 network. It is not concerned about the 10.1.3 network. Okay, and then to get to all of the other networks here, its next hop IP is 10.1.3.1. (10.1.3.1). Okay, now you're going to do a lot of the same thing. You're going to repeat those same steps for all of your other routers, all of your other branch routers, the SD 1941 1 and 2, New York 1 and 2, and SF 1 and 2. Okay, now that I showed you how to do a couple of these, can you take it from here? Okay, good. All right, so now that we have everything configured here, all the IP addresses, at least the neighbors are pingable, right? Here's what we got now. Okay, so you're going to create a blank text file here with all the routes, and then comment out anything that's directly connected from that router's perspective. Okay, and so the core router, as you can see, we're not concerned with 10.1.4, 10.1.8, 10.1.12, and 10.1.16 because those are directly connected. What we are concerned about are the routes to 10.1, 10.2, and 10.3. So those are going out 10.1.4.2. Okay, 5, 6, and 7. Okay, 5, 6, and 7. So 5 is down here, 6 is out here, and 7 is down here. So the next hop IP, so 5, 6, and 7 here, is 10.1.8. This is from the core router perspective. It's 10.1.8.2. Okay, so that means 10.1.8.2. And to the 7 network there, 10.1.8.2. Okay, 10.1.8 is directly connected, so we don't need to advertise that specifically. The next one is 10.1, 10, 11, 9, 10, and 11. Okay, 9, 10, 11. Okay, 9, 10, and 11, the next hop IP, 10.1.12.2. 9, 10, 11, so that's 10.1.12.2. Okay, and the next one is 13, 14, and 15. So that next hop IP is 10.1.16.2. Okay, and then we already got the ones for 1, 2, and 3. It's going to be via 10.1.4.2. Okay, right, so here's our core router. So we can just drop it in. Right? So now, show IP route. We can do show IP route static for all of our static routes. Here it is. 1, 2, 3, it's via 10.1.4.2. 5, 6, and 7 here are via 10.1.8.2. 10.1.10, 11, 9, 10, and 11 is via 10.1.12.2. 10.1, 13, 14, and 15 are via 10.1.16.2. Okay, see how that's working there? Okay, cool. LA 1941 is here. Okay, so you notice 10.1.2, 10.1.2 here, 10.1.3, and 10.1.4 are directly connected. So 10.1.2, 10.1.3, 10.1.4 directly connected. The route to get to 10.1.1 is out 10.1.3.2. 10.1.3.2. That's over there. Okay, the rest of it goes out this way, 10.1.4, 10.1.4.1. Show IP route static. Okay. This one now. (1941-2), right? Not concerned about the one network because it's directly connected, not concerned about the 3 network as it's directly connected. And this one, all of the routes, because this one's a stub router. That means the route to get to any of these networks is via 10.1.3.1, 10.1.3.1. Okay? There you have it. Okay, while we're here, let's just get the other routers configured. Okay, that's the SD. Okay, the second one. Okay, NY. NY, second NY router. Okay, and the SF router here. Okay, and the second one. Okay, so this one hadn't been done yet. So we could just go through it really quick. So we're not concerned about the 13 network and the 15 network. Okay, and everything is going to be going out 10.1, 15.1. 10.1, 15.1. Okay, now let's test everything. Okay, so we trace RT 10, 1, 2 to 126. Okay, and we can speed up time here. Okay, so this is dying here. Why? Show IP int brief. Brief. Okay, it's via 10.1.15.1. 10.1.15.1. That should be right here. Okay, this next hop is 10.1.16.1. Okay, then 10.1.4.2. 10.1.4.2 is up here. This should be directly connected. Yep, directly connected here. So we tried to get to the 10.1.13 network here. 10.1.13 network. Let's see if we have a route for that. Okay, 10.1.4.1 is right here. Okay, 10.1.16.2, 10.1.16.2 should be right here. Okay, so we're missing a route here, 10.1.13. Okay, so 10.1.13 here, 10.1.13. Ah, okay. So no route to 10.1.13, so let's fix it. So 10.1.13 is via 10.1.15.2. Okay. 10.1.13. Yep, so it says it's passing it off to 10.15.2. 10.1.13. Okay. So now let's see if trace completes. So that's what it takes, folks, to if you have a bad route somewhere, test all along the path forward and then test all the way back to reverse, right? So if you have that forward route all okay, come back the other way on the reverse, okay? So that means we should be able to now, hopefully, trace route 10.1.14.126. Speed up some time here. Okay, so it makes it to 15.1. 15.1 is right here. So we'll see if we have a route for 10, 1, 14, 0. Okay, so that's directly connected. Do we have a route for 10, 1, 13? Okay, 15, 1, it kind of dies right there. So, this is probably why. 10, 1, 14, 126. Okay, let's try that again. Right? Oh, that never happens in real life. Yeah, right. Trace route 10, 1, 9, 254. 10, 1, 9, 254. 10, 1, 9, 1. 10, 1, 2, 126. Okay, try it again. Much better. See if we got our server there. Okay. So far looking good. 254. And 6. All right, so far so good. 10, 1, 2, 126. And then 10, 1, 1, 254. Okay, looks like our routing's good. So from here, let's telnet to all the switches to make sure that we can get there. Okay, so far we're getting to all of them. It's a good sign. Okay, got a timeout over here. IP int brief 10.1.6, 125. No default gateway. Okay, come back over here to the host and we're good. Okay, good up on here. And here, good here. One more test. Okay, and you really should go to all the hosts and test www.abc.com. But for now, this is looking okay. All right. Okay, good. So this should get you set up for 100 points. Set up for 100 points for assignment 5. Good luck. Have fun with it. Okay.